STAR-CCM. So first we need to create a new simulation, which we have done. I've called this one example. We can go ahead and save, which I have also done. So now we'll go ahead and load the propeller geometry. So we'll go up to geometry and make a new 3D CAD model. From there we can import the propeller geometry. Great. And we want it to be facing the positive X direction, so we can rotate this body 90 degrees. All right. So we'll now define the fluid domain. We'll begin by creating a sketch on the XY plane and change the grid spacing to 0.1 meters. And we'll just create a box at -1, 0, and 1, 1, which looks right almost there. Perfect. Be okay with that. And then we'll go ahead and we can revolve this. We'll actually make this -90 degrees. We'll also want to make sure that there's no body interaction. So we'll hit none, click OK. And we'll do something similar, but just for the bottom half. So we'll create another sketch. Click OK. We'll also revolve this. That looks great. We'll make sure that there's no body interaction. So we'll now go ahead and create the fluid that's going to be rotating. We'll create a sketch in the same plane. We'll actually make the grid sizing smaller. Hit enter, and then scroll in, make another box. Perfect. So we'll go ahead and create a revolve there with similar values as previously, making sure that it doesn't merge. I'll create one last sketch. Okay. We'll also create a revolve with no body interaction. Okay. So we now need to create the, or we need to name the different bodies. So the first body we'll just call Fluid 1. The bottom we'll call Fluid 2. The top rotating we'll call Rot 1. And the bottom we'll call Rot 2. We'll also call the propeller prop. We also need to name the different faces of our bodies. So begin with this one. We'll call this in1. This is going to be symmetric on this face, so we'll call this sim1. This ought to be at free stream, so we'll call this free1. And then our pressure outlet's going to be on this back face, and we'll call this out1. You can do the same thing for the bottom. Call that out2. Call this sim2. Call this in1. Finally, we'll call this free2. Oh. That should be in2. Great. So we also need to name the faces of the rotating fluid. So I've gone ahead and hidden the top and bottom fluids. You just right click and click hide. So I've called this face front 1, called this rot sim 1, and this as back 1. And then similarly, this is back 2, rot sim 2, and front 2. So I'll go ahead and unhide or show the fluid domain. So there we are. We can close 3D CAD. So from here, we can select all these bodies and create a new geometry part for each one. Great. So we'll now go ahead and create 4 new operations. We're going to first do 2 unite operations. So we'll unite both the fluid domains. We'll call this unite fluids, or fluid. And we'll also call the new part that's been created, united fluid. Or we'll just call it fluid. We'll then go ahead and create another unite, or unite the 2 rotating fluid areas. So we'll call this unite rot. And rot. So after we have executed these 2 operations, we can go ahead and create 2 new operations. They'll both be subtracts. So we're going to want to subtract the fluid, or from the rotor fluid, from the fluid. The target part is going to be the fluid. And we're going to call this fluid minus rot. We'll call this the same part, fluid minus rot. Go ahead and execute this. We'll also the same thing, except for now we'll include the propeller and the rotating fluid. And our select object is going to be the rotating fluid. So we'll call this rotating fluid minus propeller. We'll call the part the same name. Rot minus prop. So we can then, we just want to execute it. There we go. So after we execute that, then we're going to go and we're going to assign this part to a region. So we're going to create one region for each part. Otherwise, we can just do that each. We're going to create a boundary for each part surface. I'm going to apply that. Close. And we'll do the same thing for this part. Okay. So we'll now go ahead and create a surface wrapper for the propeller. And we'll change the base size to 0.001. Should be fine. And we'll go ahead and execute this. So we can now go ahead and create a new automated mesh. We'll include the two parts that we made from our subtraction operations. We'll choose a surface remesher, polyhedral mesher, and prism layer mesher. So that looks good. And then we can execute it. So we want to click into the automated mesh and change a few things. First, we want to change the number of prism layers to 20. We're also going to want to change the prism layer stretching to 1.2. Finally, we're going to go in and we're going to change the prism layer total thickness to absolute instead of relative to base size. And that absolute size we would like to be 0.015. We also want to change we want to make 4 custom controls. So we're going to go into this automated mesh, and under custom controls, we'll do new surface control. And we can call the surface control fluid domain outer surface. We can go in and we can edit this. Alright, part surfaces. We're going to go into the fluid minus rotating, and we're going to open that up. And we're going to want all of these surfaces. So we click OK. And then for we're going to want to change the target surface size and the minimum surface size. And under values, we can change that. And we want both of those to be relative to the base. And we'll change that to be 500%. And under minimum surface size, we want that to be 100%. So we can close that, and that is good to go. So we'll go ahead and create a second new surface control. We can rename this inner puck control, which refers to the surface that the rotating fluid and the fluid domain share. So we can edit this. Our part surfaces are going to be the rotating minus propeller and all of the rotating surfaces. Click OK. Here again, we're going to want to change the target surface size as well as the minimum surface size. For those values, we're going to want to change that to be 30. And the minimum, change that to 5. So we'll go ahead and create a very similar third surface control. We'll call this outer puck control. And here we're going to choose the fluid minus the rotating and all of the rotating. So similarly, we're going to change the target surface size as well as the minimum surface size to 30. And 5. We'll create one last custom control. We'll rename it as prop. We'll go ahead and edit this. We'll choose not all of that, but rather that surface. And we're going to want to change 4 things. First, I want to change the target surface size, as well as the minimum surface size, as well as the number of layers of the prism, the total thickness, as well as the wake refinement. So if we go to values, we can change the target surface size to 5. The minimum surface size we're going to want to change to 2. The wake refinement, we want to change the relative size to 25 and the growth rate to 1.3, so those both look good. And for the custom prism values, we want to have 10 prism layers. We want to have a total prism layer thickness, an absolute thickness of 0.05 meters. This scene? Oh. So this is without running the mesh. So we can now go ahead and change the base size to 0.1 meters. And we can execute this automated mesh. So as you can see, our fluid domain actually looks pretty good. And here is our propeller. And our geometry and mesh the initial part is done.